My name is Yuzhu Lu. I working on front-end graphics. So today I'm going to talk about some of the updates. As you already know, we have high DPI support for Linux and Windows, and of course it's including graphics. And also the rasterization functionality. And we're also having texture mapping for more 3D primitives and adding a list of named vertex texture coordinates. So you don't have to figure out how to creating the texture coordinates yourself. And we also have an interactive way to picking the view center. So if you want to rotate around a certain object, you want to check more details. It's a very convenient way. And we also have some non-NPO rendering features, and which is as directives. And also, I'm going to talk about a little surface appearance. How do you use surface appearance to customize your own rendering? After that, probably talk about a little about our new join layers. We spend a lot of time on those, and these now are ready and fully implemented. So high DPI for graphics, it's supported everywhere, all join layers, all primitives, and also each component like tick labels as well. And it also supported, you can also rasterize it, convert to, and then if we take a look, we'll see there's there's bug there. Let me switch to 100%. Let's try again. So if we take a look, it will says like I'm trying to see, where is it? I didn't. Okay. And it shows, oh, okay. Yeah, that's because of the projector. So on my laptop, it will be 144, and the image data will be double the image size. Let me switch to 100. Okay. So it works with 3D as well, work with Mesa as well. So text mapping, we have text mapping for the rest of 3D primitives, and one thing I want to mention that we now have some changes. The default value of vertex texture coordinates is used to be none, but now it's automatic. So it might affect some of the examples you had previously. So before in 12, it will be like in this example, it will not apply, and it applies here. But if you want to switch to the previous one, you can either define some of the style sheet, or you can specify a texture of none directly. So texture mapping is useful, but sometimes you might get a hard time to figure out how to create a vertex texture coordinates. So we provide a list of named ones to provide to generate for you. The planner is the flat way you applying textures along or either X or Y or Z direction. So it will be like this. This is applying to Z direction, and this applies to Y direction, you can see. And there's another one called cubic. It's applying textures, all 6 textures. It will map the polygons into a cube and then apply 6 textures along those 6 faces. And the cubic is 3 direction. The box is 6 direction. So the cubic is top and bottom will be same, but the box it will be different. So yeah, it will be useful for different users. And the spherical is just trying to map the polygons to a unit sphere, and then apply it around all x, y, z directions. You can specify there's a syntax there. But sometimes you might wonder, why just x, y, z directions? What if I want to something different direction? You can do that. It works with geometry transformation. What you need to do is just transform the coordinates and then transform the whole thing back. It just applies inverse. And here's an example. So you can do different. So that means you can do any direction. Interactive view center picking. So if you hold down, it's in product already. And if you hold down Shift and Option, and it will show up picking icon. And so then what it does, it will set this object as view center. If there's nothing to pick, it might have does not change anything. But if there's anything could be hittable, then it will be changed. And yeah. So it might be useful if you have a lot of objects, you want to check in more details, some part of it. And NPO, what is NPO is it's more artistic way of rendering objects. We now have a few we have directives to support that in the product. Toon shading is quite general, and the lighting computing it is also based on the light directions. You can specify image scatter light, so the light will go with the camera, or you fixed using user coordinates. You can also specify different colors. Sorry. Or you can apply weight to them. The weight is it is about the intensity computed from the lighting computing. So and it also works with all the color data set. So you can apply different color data to see the one and pick the ones you like. Good shading is little. You will see for the toon shading, it's more. When things connecting are more, it's more sharp. It has sharp connecting. But the good shading is smooth. You will see. That's a difference, and it gives a cool to warm color transition. And steeples is so you can apply that to any graphics, 3D graphics. You can control the density of it, and it will give some different rendering. Yeah. Hatch shading is something allows you to apply the hatching style or the sketching style to any 3D graphics. Same thing, you can specify image scaled lighting or user coordinates lighting. And also you can choose to customize, because it's using textures, you can also customize using your own textures. And it might give different results, like here. And if you are not very satisfied with it, I want this part to be totally white for the highlight part. So what I did is I replaced these two with just two white textures, and we evaluate that. You will see this part is white, pure white. So you can put it in different textures. You might customize your own hatching shading yourself. Halftone, we have currently developed 5 halftone choices, like a disk, hexagon, line, square, triangle. And you can also choose the distance between them. And that all these NPO is for 3D, and for 2D we also have hatching and tiling. It will definitely work differently because it does not have lighting. For the hatching for 2D, you can control the directions. It might have more styles coming later. And it will also adopt the color with the graphics. And if you want something different, you can specify yourself. And for example, I don't know if this works. Oh, it does not. OK. OK. So all the NPO, if you look closer to it, you will see that it is built on top of textures and the surface appearance. What is surface appearance? It is a directive we are currently experimenting with, allows user to feed in GPU shadows directly, and you can choose the rendering yourself. The syntax of that is, this is one. Okay, this is one example I'm going to use, which is called the depth of field. And if we look a little closer about the structure, it has names, attributes, parameters, and mainly it will have shader programs, including the fragment shader and vertex shader. So you totally could decide what it rendered. And so it could be used to develop NPO. It could also use for customized rendering for yourself. So in this example, I'm going to show you how to do that with depth of field. So it will get blurred if there's different depths. So if we take a look at the functions, it basically just to combine the color channel and the depth channel together. And then when we have a shadow, what we did is just doing some computing based on this information. And this example, and you can control these parameters And if you go something extreme, yeah, it will be something different. But it's flexible. You can create something you like and publish it. So this it could be used applied to any data. This is our geometry 3D data. Currently, it will sample a lot, so it will be slow. But if we reduce the number it needs to be sampled, it will be the performance will be get improved. So Meta, so we now have fully implemented Meta on Mac, and currently I'm demoing with Meta, so we didn't see any problems. That means it's very close to be ready. And now let's take a look about the performance. There are some performance boosts, and so these are some numbers. For simple ones, it can get like around 10-20% performance boost, and but for those more expensive ones, you will see that it's more than double the frame rate. I can show you the difference here. It will contain, I think it contains millions of polygons in this example. And you will see the frame rate is over here. It's small. It's small. It's but still visible. You will see it's around like a 3. It's around 7 4 million polygons. And if we switch to OpenGL, OpenGL still around for option until Apple fully dropped it. So just in case if you see something driver-dependent issues, you can always fall back to, OK. Choose OpenGL. So if it is OpenGL, you will see it's like 2.2. So yeah, you will see there's a performance boost there. And this is using Intel. I'm sure you are going to get a much better numbers if you are using NVIDIA and AMD, because Meta make better use of these hardwares. And we also have fully implemented Direct 3D on Windows. And there are some numbers comparing Direct 3D 9 and 11. So same object, of course they are running on different machines. But these two are running on the same machine. You will see that for simple examples, it's getting much better performance. It's like a 80% performance boost. But if it's million, getting a little bit speed up. But I think there are possibility to getting more optimized. With the new drawing layer, we have some new features. For example, like pixel-based lighting. What is pixel-based lighting? It does lighting computing. Currently, we did lighting computing on vertex level. It's not in pixel level, but in the new drawing layer, it's computing. It could be choose to rendering on the I'm using OpenGL. So that shows it's not available in OpenGL. See, you get a much better lighting. That means you can sample less polygons and get pretty same result. And less polygons means faster. And with the new drawing layers, it also give the choice of you can choosing different graphics hardware. It will list all the available hardwares in system information. So there's a part of meta. If you have multiple hardwares, it will list it here. It also shows which one's currently in use. But my one is just only got Intel. So there's only one listed here. And if there's more, you can select hardwares for a different purpose. For example, you want to save the battery life, for example, and you can choose different preferred GPU. There are software integrated, discrete. It's not always available. All these cases are available. But if it's available on your system, on your machine, it will be applied. I'm trying to see. Now I'm going to demo something with Direct3D. If I can switch to the Windows. So stereo has been requested for different users for many years. But now we have it as a built-in feature, but it only works with Direct3D 11. We did it in the same way as Unity does. So if your hardware supports that, and you can configure that in the NVIDIA control panel. If you have the goggles, it might give you a choice, have different stereo types. Currently, we does not have much hardware right now, so we were just demoing the okay, here's my mouse. Is it prototype? Yeah, it's prototype. Okay, let's try to run this example. Yes. This is a volume rendering result applying color functions to example data. And if you hold down the left control key and try to interact with it, it will bring up the stereo window. It could also do full screen. And if you have glasses, you can see that. And then you will see the performance is pretty good as well.
What graphics card?
It's NVIDIA graphics,
Which one?
RTX.
Which number? Is it the 2000 series? Or?
Yeah, 2000 series, yeah. So this is the feature, the stereo feature with Direct3D 11. And there's, let me show you some, the system, I'm trying to see, the hardware information. I cannot see it this way. So there's a DX. It will show all the hardware currently available on your system. For my desktop, only got the software and NVIDIA. Meta does not have software, but Direct3D 11 has software. Okay, so you can choose between them using the preferred GPU option, and then it will just works. So I think my time's up. Do you have any questions?